Okay, looks like the recording has started. Welcome everybody to
Yes.
this month's, thank you, Steve. Welcome everyone to this month's Ask an Expert. This month's session will be on time enclosure. This session is being recorded right now, so participation is completely voluntary. If that makes you a little bit nervous or apprehensive, you don't have to participate at all. You can just sit back and listen to what other people have to question or have questions or have to offer or something like that. So I will be your expert for this session. My name is Stephen Elzinga. I have been in the FPGA business for nearly my entire career. It's going on a long time, 20 plus years. I've been in the training group for 6 years, almost 7 years now. It's coming up there. I have taught a wide variety of classes with FPGAs. My roles over the years have changed. I started out as an application engineer. Did that for a fairly long time. I was a design engineer for about 6 years as well. And then most recently here came into the training team for the last 6 years. I've been doing that and have been enjoying that a lot as well. So that's a little bit about me. Let's see. So yes, there's going to be some a couple of shameless plugs here. Shameless plug, but I believe that the content is completely relevant and it's good. We do have online. We call them online training. So when we create our online training and post it onto Intel's website, we usually upload those online trainings to YouTube. 9 times out of 10 we upload them. And if we don't upload them, it's probably because we just forgot to do that. In addition to online trainings, we have something called quick videos. Quick videos are short-ish, 5 minutes around that time videos that take on a particular topic, maybe something a little bit more niche. But we upload those exclusively to YouTube. That way, people can, get the information that they want quickly and then move on. Anyway, check out our YouTube channel. We have those quick videos there. So ground rules, any questions you think about time enclosure is fair game. So let me know. I can't guarantee I'll be able to answer every question. I will do my due diligence on answering questions. And if I know the answer, I'll let you know that this is what it is. If I don't know the answer, I'll use my best guess based off of my experience with FPGAs and with the software tools. If the question ends up getting a little bit too detailed, probably jot it down and refer you to your local field application engineer. So let me have your questions. The more questions that you get from the audience, the better. That way, it gets other people thinking about as like, oh yeah, I didn't think about that. Maybe that applies to my situation or my FPGA design. And then Steve.
So I'm Steve. I'll be your moderator today. So you can ask your questions in 2 ways. Either just unmute yourself over over the phone, or just put something in the chat. I'm actively monitoring the chat, and I will relay your questions to Steve as they come in. So please get your questions going, and we'll get started.
All right. So about time enclosure. Time enclosure is, we're probably a portion that takes, in FPGA design takes a significant amount of time. I say it's a significant amount of time because you end up with your design. You follow the specifications that was agreed upon by your team or by the company. You implement them. As you go through there, through the place around tools and everything, time enclosure, you ends up finding some spots that are hard for the tools to close timing. Now, when I say close timing, you have timing constraints that you've entered in with your SDC files, the synopsis design constraint file. And with that, you're telling the tools that I need to run at 300 megahertz. And as you go through there, the tools will do their best to place around the design based off of the timing constraints you have inside there. And some paths may fail. We don't want them to fail, obviously, but when they fail, what is it that you do at that point? And that is time enclosure. So you go through and you analyze your design, look at the reports, look at your design. Do you need to go back and redo the RTL code? Can you tweak some settings inside of Quartus to help with time enclosure? Can you apply different types of timing constraints to nudge the tools in the right direction? So this is time enclosure. So when you hear time enclosure, this is what we mean is that your design is not meeting timing at certain spots, and then what do you do at that point? So part of time enclosure, part of the enhancements that we're doing with Quartus when it comes to time enclosures, that the engineering team here is developing a new database. So the database, usually people don't have to worry about the database at all. They can go ahead and do their design, plug it into Quartus, and away they. Anyway, excuse me, Christian, would you mind muting yourself, please? Okay. So there's a new database being made underneath the hood inside of Quartus. With this new database, there's not going to be a new Quartus Pro version 2.0. It's going to be hopefully seamless to the customer. This new database is going to be called the Design Netlist Infrastructure. I know not a quite catchy sounding name right now. So incremental improvements along the way. It's currently available in Quartus right now, 22.4. You could go ahead and use the new database. It's beta right now. The engineering team is willing to look for feedback. And so what makes this new database, help with time enclosure? So there's going to be some features here I'm going to talk about with the Design Netlist Infrastructure, DNI for short. So you hear me refer to it as DNI from now on. Part of that is with the RTL Analyzer. So with the RTL Analyzer, what we're able to do with this new database infrastructure is do. Yes, please go ahead.
Before we dive into the DNI stuff, there is a question in the chat, and it's kind of a doozy to get started. But can we do random seed sweeps in a batch method? Do you want to comment on that?
Yes, I do. Thank you. So no time like the present to talk about seed sweeps. Why not? Let's get into it. It is a little bit of an involved topic, and so that there's going to be some a preamble. I'm going to talk about seeds, just so we're all so that everyone's up on the same page. So Quartus has this concept of seed, and so when you have a design, when you have a flip-flop, that flip-flop can be placed in, thousands of different locations inside of Quartus. Quartus has to make a decision somewhere, to place that flip-flop somewhere, right? So if you got a one flip-flop design, the solution is going to be trivial. It could be, one of any of the thousands of places that it can put in there would be equal as far as solution goes. But Quartus needs to have a starting point nonetheless. So I like to refer to that as some type of internal seed number. And so seed here is kind of an overloaded term. There's an internal seed number that Quartus uses, so it knows where to start the place and route process. So it places that single flip-flop, right? You put that up to 2 flip-flop design, 3 flip. As you can see, the number of solutions possible for the fitter, grows exponentially, and you get up to something like 16 flip-flops, and you'll never be able to find the perfect solution, for the age of the universe. So again, Quartus has to start somewhere, and it used this internal seed number. Now, the question isn't referring to an internal seed number, it's referring to an external seed number. So there is a setting that you can have inside of Quartus. It's called seed. And what you can do is you can just have that seed with that external seed number. What it does, it modifies ultimately what this internal seed number will be. There's this external seed number. Now, before I get into this external seed number, and again, the assignment is called a seed, and the fitter uses that to, again, for this whole place route process. The files. So the files that play a part in determining or in helping to determine what this internal seed number will be are the source files. So if your source files change, that will tweak this internal seed number. And as a result, the initial placement of your design will vary if your source files change. And so that's why it's probably happened to everybody here on the call that, all I did is I just changed one line of code in my HDL, and now my design is not meeting timing. It's like, well, that one line of code is all it took to change that internal seed number. With that internal seed number, the fitter started, looking for a different starting point for the place route process, and as a result of that, the timing is now not being met. And so these source files play a part in determining this internal seed number. Okay, so there's the preamble. The question is specifically about this external seed number, and I believe what is it? Is there a way to do a random seed sweeps in batch method? The answer to that is yes. Quartus is scriptable. So if you're familiar with the scripting aspects of Quartus, you go ahead and in using Tickle, or actually just using Shell. If you're running on Linux, you can have your batch file or your shell script choose have a variable and choose the number of that variable to be random if you want to. Now, in my opinion, there's no benefit on making that variable random because there's no one good seed number. So if there's no one good seed number, the seeds themselves, even if you do them sequentially, end up ultimately becoming random, so to speak, anyway. So when you go ahead and do a seed sweep, and besides that, if you do random, and if it ends up being random every single time, you want to be able to I was going to say you want to be able to lock on a particular seed number, but I guess as I'm thinking out loud about this, the good results, it would end up documenting that one particular seed number anyway. Random, in my opinion, is just as good as doing sequential. So you could do random, you could just do sequential, sequential in that you tried seed number 1 and 2 and 3.
Steve,
yes, Steve, go ahead.
Steve, yeah. I think you missed saying exactly what a seed sweep actually is.
Oh, yes, I did. Okay,
you talked about seeds, but you didn't say what a seed sweep is before you
right.
Before
Okay.
You go on. So.
Yes, thank you. So a seed sweep is when you take a bunch of seeds, these external seed numbers, this assignment seed number, and you just run through and you try a seed and you let the fitter run with that seed number. I'm just going to see seed number 1. That's a default seed number, just because you got to start somewhere. And you run through the whole place route process with that seed number. And then you go to seed number 2. And you run through the entire place route process with seed number 2 and seed number 3 and so forth. So that is a seed sweep where you take a bunch of numbers and you run through an entire place route process with that particular number. So again, back to the question there, could you do a random seed sweep, with random seed numbers? You'll get the same benefit doing random seed numbers as you would running them through sequentially. So yeah, that was a little bit of a doozy, a little bit of a preamble there. Hopefully I answered your question. Hopefully everyone has at least a little bit of an idea of what seeds do and what they can do for your design. They're good. Doing seed sweeps are good because if you need to eke out that much more performance, usually running 5 to 10 seeds, statistically speaking, that's when you get the most performance improvements out of there. You get diminishing returns past that. Now it's been shown, statistically speaking, that you can still eke out just a tiny bit more performances out of that. And when I say tiny bit more performances, what happens is that because the tools start looking for a different place to start the placement route process, some seeds are going to perform worse than other seeds, but overall, out of 20 seeds, for example, you should be able to get incremental improvements with that. And so that's kind of the idea with seed sweep. Okay, hopefully.
I think we have a question on the phone. Somebody wants to unmute and ask their question.
Yes, I have a follow-up question on that because we have designs, we have a master branch and it builds properly, and we decide to release, and then suddenly we change like the version number it did. And then suddenly we start exactly that the timing doesn't pass, and we have to try I think 10 seeds to find, instead of releasing something which worked before just because it changed one bit somewhere. Is that normal behavior, or is there a way to avoid that?
That's a very good question. So thanks for asking the question. To follow up there, I mentioned that the source files will contribute to this internal seed number. In addition to the source files doing that, the version of the software will do that as well. So depending on the version of software you're running on, also if you're running on Windows versus Linux, if you've got everything the same on Windows and then you move that entire stuff over to Linux, same version of software, same source files, the fact that you're running on Linux will also give you different results as far as this internal seed number is concerned. Now, in your case, no one likes to run into this where it's like, oh, Intel tells you like, oh, in our new version of software, we've got this and it's fixed that, but you run that and now your design doesn't meet timing. As a as a method to help reduce the variance that you have between seed values, is you can go ahead and back annotate the placements of the RAM and DSP blocks in your design. So if you found a good location for those, so if you have a fair number of RAM and DSP blocks, and I'll let you guys decide what fair number means, there's an option inside of Quartus to back annotate, and I wonder with the design I've got up, I'm just going to go ahead and exit the slides here for a minute. Give me a minute here. Hopefully this will not take very long. Okay, good. So there is under.
Okay, what I want,
Please go ahead.
We build on Linux. We have every Docker is in a Docker, every Quartus is in a Docker container.
Okay.
So it's absolutely exactly the same. It built for months properly on the master branch. Then we branch off, just change the version number from the last build, which was properly, and then it starts to fail.
Okay.
So
yeah, no, that's
yeah. It's very annoying always.
It is, yes, it is annoying, and I'm sorry that you're going through that, but yeah, the version will also play a part in this internal seed number. So
No,
yeah, unfortunately,
it's not the version of the software. It's like our internal FPGA version, so we can track what is loaded on our devices.
Okay, so I guess I don't quite appreciate what you mean by version then.
Yeah, we have some register which say which version that I like, or read-only registers, which tell.
Okay.
And we change
yes.
the content of that.
Yes. So that is a change in the HTL code. Yeah.
But it's one bit. It's one bit. Yeah, it's a couple of bits. Yeah.
Yeah. So I know. You can look at the, and I don't know if this is what the tools do exactly, but you can look at it when the tools read in the source files for that. You could look at it as like, doing some type of CRC sum or something like that. So you'll get a different CRC number if anything changes inside the HTL code. And that's what's happening in your case. I know it's just one bit. It's like, oh my gosh, the hardware is all the same, and I just changed this one little thing, and now it's failing.
Yeah.
Yes. So you can get around that by back annotating the placement assignments that you have inside there, and that does help out quite a bit. Let's see. It is.
But in our case, in our Jenkins job we have a flag to automatically try different seeds until it fits one.
Oh, okay.
So we just let it run during the weekend in worst case.
Okay, got it.
It's just that instead of having it finished on Friday, it's maybe finished on Tuesday. Yeah.
Yeah. Okay. No, I agree. It is annoying, but maybe this might be something you could consider as well if you're doing, like I said, if you've got a fair number of RAM and DSP blocks. What you could do is just go ahead and write out the location assignments of your RAM and DSP blocks, especially if your hardware is not changing. Those assignments will be good. And these assignments, when you back annotate that, they'll be written in your QSF file. It's hopefully you can minimize this kind of problem that you have with with this insignificant change that you do in your HTML code that causes the tools to think that something more is going on.
But since we have the script to do that, it's not that annoying. It's just that it's not
time.
that often. It's just I worked so long. I just happen to see it often. Every time I have to do a release, it happens. I have just bad luck.
yes, it is. It is just bad luck. Anyway, what I have here, back annotating assignments there that might help with this bad luck, and maybe mitigate how often you have to do an automatic seed sweep like you've got going on there. Okay, thank you for the follow-up. Any questions? Please go ahead.
Yeah, there's just kind of quickly related. Somebody was asking if, along with what you've mentioned so far, can what is it? Do compile results change if on Windows on one version of Quartus, but on different PCs, different Intel CPU generations, and AMD? And the answer there is yes. I mean, if you're going between different hardware and such, that can affect the seed as well. right?
Yeah, it was my understanding that's actually only the version of Windows, only the version of the OS that you're running on, not necessarily the
Oh,
hardware
oh,
that
okay.
that you're running on. Yeah. So if Windows 10 versus Windows 11, that'll play a part. Windows versus Linux, that'll play a part. Um, the Theory has mentioned that he had all of his in a Docker, of course, installed in a Docker, which is all self-contained. I don't know enough about Dockers to fully appreciate that. It was my understanding that everything's all self-contained. You can move that Docker, from OS to OS, and you should get the same results with that. That's my understanding of Dockers. I could be wrong about that. No.
Okay, great. Thank you.
Uh-huh. Okay. Any other questions that come in?
Not right now.
Okay, perfect. Feel free to interrupt, with the presentation that I've got going on here, if you want to. But like I said, this new database is supposed to be helpful. There are some features that are coming as a result of this new database to help with time enclosure features. So that's why I have this up here. Okay. So part of the new features that we're able to get with this new database inside of Quartus is more RTL viewers. And so we have so if you remember, inside of Quartus, there's usually only just one RTL viewer here, but with the DNI, and if you launch Quartus with the --DNI switch, these 3 extra RTL viewers come up. He says, okay, well, what's so special about those extra RTL viewers? So the first one, elaborated, that shows you basically what your RTL is supposed to be. Instrumented. Instrumented is it allows you to insert signal tap cores inside of there. It's a feature we haven't yet implemented inside of Quartus yet, but that is upcoming. 3 is constrained. So constrained is when the constraints that you have inside your SDC file that target your RTL code are read in. Then 4, swept, that is when the optimizations from the synthesis tool has happened inside of your design. So those are the 4 different versions. So if you open up the RTL view number 4, for example, that will give you a view of your RTL code with the optimizations that have happened. With the RTL Analyzer viewer, you can go ahead and take a look at what the sweep hints, the optimizations, what they are going to be, and you go ahead and investigate, why optimizations are happening inside your design. And when it comes to RTL, optimizations happen in RTL generally because something is not connected. When I say something's not connected, the output port's not connected, the input port's not connected, clock isn't connected, something like that. Or you end up with a constant value on the input somewhere. When you have a constant value in the input, or stuff's not connected out, that trickles through the entire design and things get removed. But when you have a large RTL design, that could be tricky to track down as to, okay, so you probably can appreciate is, okay, something's at a constant value or something's not connected. I don't know how this got affected. And with these sweep hints reports that you can generate, it helps you track that down a little bit easier. So as you go through, here I'm at the hierarchy tab, gives you the percentage of information, or it gives you the percentage of components that are going to be removed from the design. Go to the sweep hints tab, you can go ahead and find out more information about a particular object. So that's what I did. I went ahead and clicked on the filter options. I put in a particular object that I was interested in. I just go ahead and show hint trace, and with that, I'm able to trace from that object back through there to find out what wasn't connected, or what was tied to a constant value that is causing, in this case, my MUX37 to be optimized away. So that is the sweep hints viewer, one of the features that is enabled with the DNI netlist. Now, I talk about the DNI netlist. If you run this, again, it's a beta feature. Our engineering team is interested in the feedback because they really want this to be robust and solid. Currently, with 22.4, where it's been released as a beta, you cannot generate a bit stream for that. But if I remember correctly, in 23.1, it'll still be a beta, but you should be able to generate a bit stream at that point. Okay, so another feature not necessarily tied directly with time enclosure, but you're able to view interfaces. I'm talking about interfaces as it relates to system Verilog. So if you have interfaces inside your system Verilog design, this is what it would look like in here. I just have an interface at the top there. I see all the components of my interface there, and I can go ahead and click on the plus sign to expand the components even more, so you can see what your interface is comprised of. To get to this interface view, all I did was I just did a right click on the normal RTL viewer tab there, and I said new tab with interface, and so I was able to view my component with interfaces there. So that is some of the new features with DNI, hopefully to help with timing closure. Now, another feature that has been enabled, or another feature that exists because of this new DNI database, is what's called SDC and RTL. So SDC is your timing constraints, and SDC, synopsis design constraints, is where you enter in all of your timing constraints. It's traditionally what you have done inside of Quartus is that the SDC, the objects inside the SDC target objects that are inside of the net list after it's been synthesized. So before it goes into the Quartus tools, and so which means you have to be inside the tools if you want to know the objects, and hopefully the objects are still there. And most of the time it's not a problem. But part of the new features with this DNI is that you're able to place SDC commands directly on your RTL code. So objects inside your RTL, you can go ahead and place the SDC there. And so what you end up doing is you end up creating a special SDC file when you do the file new. In fact, let me bring this up here. If I were to do file new, bring this into view. There we go. Synopsis design constraints file based on RTL names. So you click on that, and what that tells the tools is that, okay, so I have an SDC file that's based on RTL names. So you based on RTL names, you're able to place it on those objects. Now, here's just a small example, simple example of some SDC commands being placed on RTL names. Now notice here, we've got the DNI. Again, DNI stands for Design Netlist Infrastructure. It's the new database that's coming inside of Quartus. We have to prefix the collections that we're doing with the DNI : : So that lets the tools know that you are targeting an object inside of the RTL code. So here we have an object inside of the RTL code, which is U0. Go ahead and do a create clock on the ports, create generated clock, and so forth. Again, all these collections are prefixed with the DNI : : And okay, and then after you have your SDC constraints inside there, if you recall, one of the RTL viewers that come in is the constraint viewer. So if you want to see the constraints applied to your RTL code, you go ahead and open up RTL viewer number 3. And then from there, you can go ahead and generate reports to verify that the RTL commands, that the SDC commands made it onto the RTL themselves. And so here I'm in RTL viewer number 3. I went ahead and did right click on this for the looking at the properties for this particular object. And from there, I can see the constraints that were applied to that pin there. Along with that, you could do an early timing analysis. So you can do a timing analysis on your synthesis net list to see how things look like. Of course, you want to do a full timing. You want to do timing analysis sign off after the entire placement out and finalize has happened inside of the Quartus. Okay, that is the.
Hey, Steve.
That is the features. Yes, Steve. Yeah, go ahead.
I have a question actually.
Yes.
So does adding SDC to your RTL, does that basically maintain the names that you have in your code through compilation? So it's kind of like a preserve?
That's a good question. And when I was going through these trainings, that question came up, and I can't remember the answer. I can't remember if it acts as a preserve, or if that could be optimized away as well. I'm going to write that question down. Let me find out, because that's an important question to understand.
I would hope that if you're using the SDC on RTL feature, that's basically like using preserve on something.
Yeah, that's my guess too, but I don't know for sure. So let me find that out.
Okay, in the chat, do you recommend, got a question, do you recommend different SDC files for each step? Each step of what? I guess is my question for the question.
So I think the question probably, do you recommend SDC files, targeting the RTL and SDC files, doing I'm just going to say
Okay.
the normal flow.
Yeah.
The So you don't want to overlap your SDC constraints, because then there comes in a prioritization as to which SDC command will have precedence. And I'm inclined to say that the SDC on RTL would have precedence over SDC files that you apply, SDC commands that you apply afterwards. But yeah, if your SDC commands start overlapping, for example, if you have an SDC command inside the RTL, then you have an SDC command that's targeting the net list. That SDC command targeting the net list was more general than the RTL. Does the SDC command targeting the net list, does that override everything about the SDC on the RTL? Or at that point it gets a little. You have to appreciate very well what the prioritization is for those SDC commands. When they start overlapping. So what I would do is. If I was targeting SDC on RTL, I would have that entity or module specifically, and that SDC targeting the objects inside there. And then if I needed SDC for the net list, I would make sure that I would not target anything that was covered by the SDC on RTL. That's what I would do.
The chat question clarifies one for synthesis and one for fitter, but I mean, there's really usually you have one SDC file for your project and SDC in your RTL code.
Yeah, there is the see if I can bring up Quartus again. You could actually have a number of SDC files, and with this, let's see, it's been a long time since I've done this, but you can associate a particular you can have an SDC file target specifically a module, and the properties of that module can accept an SDC file, and that SDC file can be one that is for the fitter. So you can't actually have multiple SDC files. So it just depends on your design environment. What makes more sense? Does it make more sense to have one SDC file that targets everything all at once, or do you have an SDC file that targets RTL? And so what we're doing here is we're really trying to empower our customers in that they might be creating modules inside of the HTML code, and these modules might be a little bit more portable. So if these modules are portable, then it makes sense that these SDC files are attached to these specific modules with SDC on RTL. That way, these modules or entities can be used like an IP inside your company. That way you can go ahead and have a repository of your HTML code along with their associated SDC files. Makes it easier to be more portable that way.
Okay. There's another question in the chat. It's not really time enclosure specific, so so I can answer it if you can, Steve. But any hints as how to preserve nets for signal tap and that are constantly getting eliminated, even though they're part of the final circuit? No prune isn't supported anymore.
Steve, that is your forte. I will let you.
That is my area.
Yes.
Yeah. In recent versions of Pro, we have the preserve for debug feature specifically for this purpose, where you can enable assignments on individual signals that will then have I forget, there's 5 synthesis attributes that get applied to them so that they are guaranteed to survive through the compilation process, so that you can then use a filter in signal tap to actually tap those signals. So the chat continues on saying it should automatically get preserved if something is chosen in signal tap. The problem is that if you have chosen a signal, it depends on whether you've chosen a pre-synthesis or a post-fit signal. it may not be able to be preserved, but now we actually have a dedicated assignment for preserving signals specifically for purposes of debug. So anyway, Steve, sorry, there's no other questions at this moment. If you want to just go over the links, I'm going to be putting stuff in the chat.
Yes, so we do have timing closure related training. There is there's an instructor-led class that's taught. I believe the cadence on that is about once every 2 months. So sign up for that. So we have in that timing closure class, what we do is we go over a lot of the we go there's a lot of reports in Quartus. We go over a fraction of the reports inside of Quartus, but the intent is to get you out of a rut of looking at your favorite reports all the time. We explore some of the other reports that maybe you don't look at as frequently, talk about how they relate to your design, and do an analysis that way. And also inside of the class, we talk about some ideas on what you can do to improve your designs. And so not using just one method, but exploring a variety of methods, because there's going to be timing closure can be a difficult problem to solve, and you want to be able to appreciate and understand the varieties of methods that exist to help you close timing. So that's what we have with the instructor-led timing closure class. We do have some online courses, and these online courses I believe you can find on YouTube as well. The Design Space Explorer is nice. I like Design Space Explorer. It's you're able to easily do a seed sweep inside of a GUI. It's easy to set up, and so if you're new to Quartus, not so comfortable with the whole scripting aspect of it, you can open up your design inside of Design Space Explorer and go ahead and set up the parameters that you want, and let Design Space Explorer run through all sorts of different compilation methods, running all sorts of different seed sweeps that way.
Somebody's asking in the chat, Steve, about the roadmap for the roadmap for the DNI features. Like, when is that stuff available?
So currently scheduled. Schedules change, right? So currently scheduled, if I remember correctly, the DNI is supposed to be production release. It was either 23.3 or 23.4. So the second half of this year, essentially.
Okay. So you can just use that -- DNI switch today with 22.4, right?
Yes, you can. Let's get back there. There we go. --DNI. So we launched Quartus --DNI, and what I've done for to make it easy, do however you want. But I just went ahead and modified the shortcut that I have where Quartus is installed on my Windows computer. I just modified the shortcut to include the --DNI switches. So whenever I launch Quartus, it always launches with that feature. But like I mentioned before, 22.4 version of Quartus beta features, again, it's beta, I can't stress that enough, but you can't generate a bit stream with that. So if you're curious about these different features, go ahead and give them a try. Ultimately, you'll probably want to generate a bit stream. You'll have to take the --DNI switch off right now to generate a bit stream.
Another question in the chat just came up before you get into the rest of those links. How to improve recovery slack for big IPs like FFT?
Yeah,
that's a tricky one.
That is a tricky one, because it is an IP that you have there. The recovery and removal, it sounds like we're talking about resets. I'm not familiar with the FFT core itself, and so I'm not sure how involved it is. How to improve that?
I would say
okay. So I guess a follow-up question there is with the recovery is I'm assuming it's on the reset going into the FFT. Is that accurate? Yeah, I don't know. Well, okay. Yeah. So if we're talking about the recovery, or we're talking about an asynchronous, it sounds like an asynchronous reset. If that's the case, and how to improve the recovery timing, it could be the matter of so if it's an asynchronous reset, Let's see. Boy, I don't know. Okay, so one thing that I would try with that is if it's on the reset, what I would do is, even though it's an asynchronous reset, I would still, with that reset signal, I'd still synchronize it as it's coming into the FPGA, and I'd synchronize it to a flip-flop. Have a synchronizer circuit for the flip-flop, and the flip-flop that synchronizes the reset would be in the same clock domain that the FFT core is. And then at that point, still it's an asynchronous reset, so you still want the the false path on that listed as well. But at that point, you're kind of left to the whims of the fitter to try and place that synchronizer flip-flop as close to the resets as possible, the FFT core. That's the approach that I would take.
Probably a chain of, 2 or maybe 3, just a standard synchronizer chain, right?
Yes, that's correct. Yeah. In fact, that's a let me go ahead and switch slides here. I've got, this is from the timing closure class. I have, if I could get it quickly. Yeah, there we go. It's good. Jump to the main one here. So here we've got the synchronizer circuit, and recommend, even though it's asynchronous reset, you'll still want to synchronize that reset that's coming in, and it's coming off chip, going on chip. And so here we see 4 registers. 2 is generally good enough. 3, it's gonna mitigate as much as possible any types of problems. So here we have coming from clock domain A, then clock domain B for reset. You don't have to have these 2 separate clock domains, but you do want a synchronizer chain as shown here. Clock B would be in the same clock domain as your FFT core is. Then here I've got the constraints listed for that synchronizer chain. What we see here are QSF settings, synchronizer identification, forced if asynchronous. And so the tools, Quartus does a good job at recognizing a synchronizer chain. And when it does that, what the tools will do is they will place the synchronizer registers as close to one another as possible. So you can look at it as like a soft constraint, right? When you say as close as possible, it's like, okay, that's, there's what's the outcome of that? It's like, well, the tools will try to place them together as close as possible because it recognizes that that's a synchronizer chain there. So their identification, forced if asynchronous. So all I'm doing is, instead of relying on the tools to figure out the synchronizer chain, you can go ahead and force the situation. Force if asynchronous. So in other words, if it's asynchronous like there, you're going to force it. It's like, okay, this is a synchronizer chain. Here, by default, inside of Quartus, if you were to open up the Quartus defaults file, the QDF, you see the setting right there, and the setting would be set to 3. So I have this listed there just for definition purposes, so everyone understands what's going on there. You could also set it up locally, and you could also change this if you want to. If you don't like the default of 3, if you want a default of 2 for length, you go ahead and change that to 2. Here, this is a local assignment. So here we have got a global assignment. We have a local assignment, set instance assignment, synchronizer register chain length 3. So I'm just forcing the situation on R2, forcing it to 3 there. And again, when the tools recognize that this is a synchronizer chain, it will try to place these registers as close together as possible. Thereby, you get as much slack, or you mitigate medicibility problems. Then we go through here and set up constraints for this particular circuit. Now, in the event of the asynchronous, even if it's asynchronous reset, these constraints would still be good. I was going through the process of creating the clocks. Go ahead and create the clock groups to say that clock A and clock B are asynchronous to each other. You don't have to worry about this for the asynchronous reset. But here we have a max skew, and a max skew is good if you've got excuse me, if you've got an entire bus. You want to specify that 1 bit cannot be excuse me. Let me pause for just a minute. I'm going to get a drink.
While Steve is just taking a sip, we got about 15 minutes left, so please get your questions in.
Okay, so the The max skew, you want to skew, you want to minimize the skew between bits of a bus. So here I'm going to tolerate a skew of the source clock period multiplier of 0.8. So the source clock period, clock A, is at 10 nanoseconds. That means I can tolerate a skew between bits of a bus of 8 nanoseconds. That's what the max skew is. So you don't want one bit coming in, 1 nanosecond, then another bit coming in at 20 nanoseconds, right? I mean, you've declared, you basically set this false path. The tools could do whatever they want, but you're constraining it. He's like, okay, tools, you can do whatever you want, but there's only a certain amount of skew that I want. Then data delay, set data delay from R1 to R2. So not only am I giving the tools a constraint as far as the skew between the bits of the bus are, but now I have a data delay. It's like, okay, so yeah, it is a false path, but really I want the data to arrive from R1 to R2, destination clock period value multiplier of 0.9. So this is where you go from one clock domain to another clock domain, and then you have your synchronizer circuit that way. So that's the synchronizer clarified there.
So there was a separate mention in the chat. Somebody mentioned about stop using set clock groups -asynchronous, though I think I'm because it was hiding accidental clock crossings. But I think you do need to use that when you're doing a clock domain crossing like this, don't you?
We are using false paths between the specific registers.
Yes, and so that's a very good point. And so you could accidentally cut paths that you're not intending to, because here, with the set false paths, you have to be very specific. From a node to another node with the set false path. With the clock groups, it's going to be from A to B and from B to A. You might not want all of that together. You might want to put the false path there because, like I said, you're targeting. You have to go from A to B, and if you want to go from B to A, you have to put another set false path in there. So yeah, there is that difference between the set false path and set clock groups. So depending on your situation, choose your SDC command appropriately. That's a good point.
Okay, no questions at this. Oh, wait, no, we just got a question. Is there a template for doing, I presume that means clock domain crossing on a data bus, which includes constraints, templates for SDC, I guess is the question.
Yes, I don't think so. It's it's pretty standard, right? I mean, here I've got a slide. I've got all up. It's like, this is all you need to do. Just put that in there. It's like, well, okay, if this is all you need to do, then how come there's a template for it? You're right, there should be. And if you want to follow that train of thought a little bit longer, it's like, well, okay, if this is all you need to do, is there an IP core that does this for me, going from one clock domain to another? Because then you've got the synchronizer there. You've got your SDC constraint that's tied to that module, or you've got the SDC and RTL. Just make it easy for the customer. I hear you. There's not an IP core. Why there's not, I'm not exactly sure, but it would make our designers' lives a little bit easier to be able to insert a synchronizer as you go from one clock domain to another clock domain. But there's not also.
Steve, do you want to finish up with the links, and then we'll go look for any more questions?
Yes. Okay. There we go. And okay, talked about that. All right. My laser pointer. Okay, so user guide for Time Analyzer. Obviously check that out to understand how Time Analyzer works. There is some application notes that we have about time enclosure with the Pro Edition, and then time enclosure methodology for advanced FPGA design. So we do have a lot of material out there. We have the online class, like I talked about, the instructor-led class. We have these links there. I think that covers the links that I have available there.
Okay. So let's see what other questions we've got. Overconstraining. You want to talk a little bit about overconstraining? I've got a question about using overconstraining, and it's worked in the past. Was going to try it on a current project, but it was no longer recommended. Do you want to comment on the idea of overconstraining and how to use it today?
Yes. Hopefully I can quickly go through these slides, I do talk about, let's see, do talk about overconstraining in the timing closure class. It's nice to have a visual. I can't think this is it. Okay. Okay, good. Yeah, this will work. Okay, so there's a number of different ways to overconstrain. Probably the easiest to think of is like, okay, I've created my clock, I've created it at 10 nanoseconds, but it's failing timing. What if I go ahead and put that clock up to 9 nanoseconds, right? You're overconstraining at that point. So a couple things are happening. Couple things are happening when you do something like that. So you're changing the SDC file, right, which is a source file, which causes an internal seed to change as well. So potentially, you're tweaking the seed number. So you're basically doing a little version of a seed sweep by making this this innocuous change. But also, what you're doing is that if you have multiple clocks inside your design, it might be that you're upping the priority of that particular clock path to a different priority level internally in the tools. So you're blasting an entire clock domain by trying to make it go faster. There's always potential for that. However, you're probably better off doing a more targeted approach. And a more targeted approach here on this slide here is a good example of that, where let me go ahead and go in presentation mode, where my normal constraint is all right. Normal constraint is 5 nanoseconds, for a clock domain. But what I'm looking at here is we're using some tickle functions that come included with Quartus. Is it post route? So in other words, are you finished with the place of route? In other words, are you in timing analyzer, right? If you're looking at timing analyzer, we have that not inside there. So in other words, what we're doing here is we're setting a constraint that will apply only to the place of route process. If we're outside of the place of route process, that's what this is saying, that use the normal 5 nanosecond clock domain. During place of route, so we're doing a set max delay. We're being very targeted on a path that is failing source register, destination register. So we looked at our time reports, we see the path that's failing, we go ahead and set max delay there, and we go ahead and overconstrain. Now what happens here is a set max delay is a timing exception. Because it's a timing exception, it has a higher priority than your regular crate clock constraint. Because it has a higher priority, you're telling the tools to focus on this path here before focusing on places elsewhere. Now, always when you do something like this, if you tell the tools to concentrate on a particular area of the design, that means other areas of the design are not going to get as much work. And so when you do this, there's a chance that this path will now pass timing, but there's a potential that other paths will fail timing at that point. So this is the idea of overconstraining. Again, we are just getting out of our normal 5 nanosecond clock that we've created, setting a max delay that will be appropriate only for the place and route, and that max delay constraint is 4.7 nanoseconds, targeting a very specific path. So that's the idea with overconstraining there. So this way, if the place and route tools can only get 4.9 nanoseconds, it's quote failing, but it's not really, because you're targeting 5 nanoseconds anyway. So when you open up in timing analyzer and you analyze the design, timing analyzer will not read in this constraint there. It'll just look at the 5 nanosecond clock domain constraint there. So yes, overconstraining does have the benefit of telling the tools that I want you to place a higher priority on this path than the other paths there to achieve timing closure. But like I said, the downside is that as a result of doing that, the other areas of the design might suffer a bit as a result. But this is a completely valid and successful way to close timing.
Okay, sounds great. Questions coming in the chat the last couple of minutes here. What can cause registers to not be duplicated? That's interesting. I usually see they don't want it duplicated, but what can cause registers to not be duplicated? We have seen several times that certain modes can have very large fan out, resulting in timing issues and routing congestion. But if we manually duplicate the source register, the fan out is reduced. So what prevents register duplication, Steve?
Yeah, so there's a what will prevent register duplications if there's timing constraints on that particular register, but it sounds like that's not the case in this instance here. There's a threshold internally in the tools of when the tools decide that it needs to start duplicating registers. I don't know what that threshold is, but it sounds like that the tools did not reach that threshold there in your instance, and it sounds like you found a completely acceptable workaround by doing that. That's what I say. Internally there's a threshold, but we also have these assignments available to you to override what the tools thinks is doing best. Don't get me wrong. I think Quartus does a fantastic time the majority of the time. It does a great job. Every now and then you need to go ahead and nudge Quartus in the right direction, and it sounds like that's exactly what you're doing there.
Yeah, like Mac, you could use max fan out,
right,
or some of the other assignments.
Yeah, let's see. Let me exit this. I actually do talk about that here. I just don't know if I'll be able to quickly get to that spot. Let's see. There
you go. I see it right there.
Yeah. Yeah. So there's a max fan out. The max fan out will override this internal threshold that we have there. So you can go ahead and this is inside of Assignments Editor, easy to access inside of Quartus. You can go ahead and set that to what you want, targeting the object inside of your design. There is something else called duplicate register. So all these behave in very similar ways, but are used for different scenarios inside of a design. In this case here, this is the QSF assignment that we see there, duplicate register. And then the -2 is the -2 is the register. The register name there. I got to change the slide. That's what this means here. Is the register instance name there, and then how many times you want it duplicated. So this is very targeted there. And so here we're targeting reg, and the number sign there means we're duplicating it 50 times. And so that is the duplicate register assignment. There's some qualifications that have to happen with that particular assignment as well. For the sake of time, I'm not going to go through those. And we have something else.
Steve,
please go ahead.
On
Yes.
that slide, what you have right now, so they actually mention in the question that they have put the preserve attribute on the source register, and that itself is probably is preventing the duplication.
Yes, that's correct.
Yeah.
So that'll do that. So instead of using the preserve attribute, thanks for pointing that out, Steve. You want to use something called preserve sin only. If you have the preserve on there, maybe it's because this tool is optimizing that register, collapsing it into one or something of that nature. So you want to use a synthesis only attribute for that. And let me just throw up there Verilog there. Verilog seems to be a little more popular these days than VHDL. So we have a preserve syn only attached to this registry here. So this way, this will only affect synthesis, and then the fitter will be able to go ahead and duplicate the register as it sees fit. This is an attribute that's only for synthesis and not for the place and route tools.
All right. Okay, I think that's about it. Steve, you want to put up the final slides and we'll end the stop
yes,
recording?
I do.
At the end?
Yeah, let's do that. And all right. Thanks everyone for attending. Thank you for the questions coming in. I think we had a good discussion. Hopefully everyone is excited about the new DNI features. If you're not so excited, well, just wait until this becomes full featured. Then hopefully you won't see any degradation as a result of the new database inside there. And yes, thanks everyone for attending, and look forward to seeing everyone in our next month's Ask an Expert session. Thank you.
Thank you, everybody.